Alright. Hey guys, it's me again. Sorry I've been a little busy over the week with my work and school. So I'm sorry for making the video on the weekend. I know you guys trying to stay away from homework on the weekend, but I'll try to keep this brief so you guys can look over it either Sunday or Monday when you have free time. Let's get started. Okay, first question. Is proton bigger or smaller than an atom? So to be able to do this, you got to know the difference between an atom and a proton, right? I would draw it out for you. So proton is a positive charge component of an atom. And then neutron should be the one that's neutral. So I put N for neutral. Just remember neutron, neutral, right? And then electron is the one that's orbiting, negative charge. Usually it's gonna be like the first shell is gonna be 2. Then the second shell it's gonna be more, depending on the molecules. But you go into more detail about that later. So this part is called the nucleus. So it's only this part. The proton and the neutron together is called the nucleus. And this whole big thing is called an atom. So when you compare the proton, which is this one, with the atom, which is the whole thing, it's quite obvious, right? Which one is bigger, right? Okay, so that will answer question number 1. Yeah. And then for question number 2, all right? So moving proton, right? Proton moving and hit another proton. This one will hit this one, then creating some energy. Then they will shatter out, and whatever's unit is smaller than the proton would be released, creating new matters like the the anti-mesons, all those things. So these little things can create new matters, which was answer our question. So the answer is why? Yes, yes. So that is that. You don't have to know like how it works or go into too much detail about it. Okay? Suppose a man has twice as much mass as his wife. Energy of mass. Energy of mass is this. It's the Einstein equation. So it's E equals mc squared, where c is the constant. It's a constant. In algebra, when you say a constant, it means a number that doesn't change. Like let's say, like the gravitational acceleration constant was 9.8. This number doesn't change no matter where you're on Earth. Well, technically it would change a little bit, but it generally doesn't change much. They call it a constant. So anything that is called a constant means that the number doesn't change, the value doesn't change. And then m is mass. It's your weight, your mass. And then this is energy. E is generally for energy. So we'll delete to cover this real quick. So we have the equation E equals mc squared. So let's say this is the mass of the wife, right? We don't need to know the specific number because for this problem, we don't need to use the number to solve for it. So the man has twice as much mass of his wife, right? So the man would be 2m because m is the wife's mass. So he's double the mass of the wife. C is a constant, so C doesn't change. They didn't say anything about, different C, so different speed of light. So it's the same. And in algebra, whenever you do multiplication, division, addition, subtraction, you have to do it on both sides so you keep the equation valid. So it's gonna be 2e, 2 times 2 on this 2m, so you gotta do 2 on the E, and that is how much your energy of mass is changing. And by comparing 1e and 2e, I think you know which one is bigger, right? Which one is more energy of mass, right? Okay. So for question over here, so I usually imagine a planet is a neutral charge, like how I would imagine like a neutron. So this is Mars, and then this is Sun. They don't have charge, so they plus or minus 0, so they don't have no charge. So they don't really attract each other electromagnetically. So this force can be omit, and generally electromagnetic force, the range is smaller than the gravitational force, which can span like relatively large depending on how strong the force is. And between like two big planet, the gravitational force is really big. That's why it keeps each other at the same place since it orbits it. So the answer is gravitational. All right. Nucleus are typical 7 proton, 7 neutron, 2 proton repel neutron. So remember, right? Neutron, neutral, no charge. And proton, more, so plus charge, positive charge. So electromagnetic force is like repel, difference, attracts. So it's attracting this force over. Actually, it will attract this one over here. And then the red one is the proton attracting the electron to the proton. So opposite attracts, like repel. All right. Okay, so for this question, proton and neutron, do they attract or no? They don't attract because one is neutral charge, one is positive. They don't attract each other. They don't repel either. So they're just there. They're just minding their own business. All right. What force overcomes their protons? Okay, so two proton, right? They are both positive. Generally, they would be pushing each other out, repulsion. But in an atom, if there's two proton in the nucleus and they keep pushing each other out, it depends on time until that atom fall apart because these things gonna keep moving further and further away from each other, making the atom collapse. So in order to stop that from happening, there's another force called strong force, which I have it right here. So they are an attractive force. Oh, they are an attractive force. Oh, so they are an attractive force, and they act inside the nucleus right there, and act over the nuclear distance. Nuclear distance is basically within the nucleus because it's small. Hold the nucleus stable. That's what it does. So remember, there's only the proton and the neutron in the nucleus. All right. So these things would be constantly pushing each other out. I will use the red arrow for electromagnetic force, and I will use the green arrow for the strong force. Well, the strong force hold these together. And since strong force is stronger, because, it's called strong, right? So they hold it more tightly than the electromagnetic force is pushing out, making this cancel out, making the electromagnetic force cannot push anything out. Because if you look at the factor, strong force is 1, but electromagnetic force is 1 over 137. So it's quite smaller than the strong force. So yeah. So the answer is strong. Sorry, I might be, rambling a lot because I was a little tired. I started my shift at 4 this morning and just got home at 4 p.m. So, all right, let's start on the next one. Okay. Water molecule is formed when two hydrogen atoms attach themselves to an oxygen atom. What kind of force produces this attachment? Okay, so to know this, you gotta know the hydrogen atom and the usually probably use hydrogen as blue, and then oxygen is O, right? So usually you don't have to know this, but oxygen is bigger than hydrogen, and oxygen carry a -2 charge, so 2 negative charge, and then a hydrogen carries a 1 positive charge, right? So if you look at it, right, there's 2 hydrogens, so 2 plus charge, and then there's 2 negative charge on the oxygen. So they would attract each other because one is different. You know, this one would go over here, and then this one would go over here. So different attracts, right? So the charge would be plus or minus 0 charge because there's no charge. And what is the charge that have to do with? What is the force that have to do with the charge? It is electromagnetic, right? And then this is a structure of the water molecule, by the way, just if you're curious. I usually make this looks a little smaller. And then these are called lone pairs. You don't have to know that by now. It will be in chem if you going to take chem. But it's really cool. It's really cool concepts. Because these two molecules are holding each other based on their charges. So this is electromagnetic force. Two strong force attract, repel, or they only attract. Okay. This one I think we covered in class, right? So if I have two proton like this, if they only attract, if they only go in, right, they would be mush into one molecule and they will become just one single point, which will make the whole atom collapse. That's what they call it, being collapsed, because this force keep pulling it in, and then at one point they will collapse. So this one would be, it's not generally favorable. So there has to be a force that it attracts in, but there's also some force repelling each other until, when it gets too close. You know what? I think at this distance, I would draw it better. At this distance, they're still attracting, but at this distance, they will start it repelling, because when they get too close, they don't want it to become one point. Well, there's one force. The force attracting is still there. So it keeps, the molecule, the protons balanced like this one. So they don't collapse, but they don't fall apart. So the answer for this is both. Hey, question 10. So if we recall our force table, I'll bring it down here so it's easier for you to look at, right? So if we look over all the forces we have, gravitational force, right? Then weak force, electromagnetic force, and strong force. Which one works with the meson, the pi meson, electron, neutrino? These are very small. They called I think they're called what are they called? Nuclear. I don't know. I can't recall the specific terms for it right now, but they're very small. They're within the nucleus. Very small. Even smaller than the proton. So if you look over here, inside the nucleus, right, acts only over nuclear distance. Nuclear distance is basically the distance within the nucleus, because really, really small. They're really small. And this force is the main driving force for decay, nuclear decay, beta decay, all those things. You probably won't have to go over it until you get to Chem 4. So if you don't like these concepts, you probably won't like Chem 4, but it's really interesting. I encourage you, if you like science, you can take all the courses for Chem and physics. Learn a lot of new things. But yeah, so these are within the nucleus, right? These tiny things. Well, the electron is not within the nucleus, but these things are. These things, since they're so small, they are affected by the weak force, because these are the driving force for nuclear decay. And if you pay attention on this, it says were to decay, were to decay. So the driving force for decay is weak force. So yeah, the answer is weak force. Actually, yeah, since the pi meson is decaying into an electron, and this one, so I think this one is the only one that is in the within the nucleus. So yeah, I think I messed up that part. I'm sorry. Yeah, it's been a while since I covered these concepts, so I kind of like forget them a little bit. All right, let's move it up and get to Yitzhak Special 3.1. Okay. For this problem, I think it's easiest if you think about it this way. So there's three types of planet, right? The white star, collapsed star. There's a white dwarf, a neutron star, and a black hole. And each of this is named based on the weight that their original weight compared to the sun. So for a star to be considered a white dwarf after they collapse, they have to weigh less than 1.3 times the mass of the sun. So let's say if they have, 0.5 mass of the sun, they're a white dwarf, right? But if they are, let's say they're 1.4 mass of the sun, they are not a white dwarf, but they will be the neutron star, because neutron star is 1.3 to 3 times the mass of the sun. These are just like, you don't really have to know the math about this, but you just gotta know the concept of it, like the gatekeeping factor. So it's 1.3 to 3, and then less than 1.3 and more than 3. So if it's 1.4, the mass of the sun, then it would be a neutron star, right? And if it's 2.9, it's also a neutron star. Mass of sun, then it would be a neutron star. And finally, if it's more than 3, let's say 3.1, then it would be mass sun, then it would be a black hole. And based on the identity of the collapsed star, the radius is always these, so it doesn't change, so you can do it accordingly to the table. So I encourage having it, writing out the table, both for the star masses and name, and the force table, so you can remember it better. And if there's some homework you need to do on it, you can just pull it out and do it from there. But yeah, and pay more attention on less than, which is less than 1.3. So if it's 1.3, it is not a white dwarf. It is a neutron star because this one is 1.3 to 3, so it's the same as 1.3 less or minus than a neutron star less or minus. I mean less or equal to 3. And then lastly is more than 3, right? More than 3. So it's gotta be bigger than 3, which is the black hole. Black hole. Yeah, I kind of have them out of order, making them a little messy. Let me write it again. Actually write it again. I think it'd be better to look at. Okay, so if it's less than 3, you pay attention at less than, it's white dwarf, right? So it would be white dwarf is less than 1.3 mass of the sun. This one's 1.3 to 3, and this is neutron star, right? So 1.3 mass sun less than or equals to neutron star less than or equals to 3. So within this range, from here to here, it is the neutron star. This is kind of like my way of making it easier for you using the an equation, but generally you don't have to do this way. Do it this way. And then 3 times it's black hole. So black hole larger than 3 m sun. So yeah, let's go over some problem on this, yeah? This is just general knowledge that you gotta remember. You don't, there's really no math to this part. Okay, let's say if it's, 2.1 mass of the sun, what would it be? So according to this falls in between this, so it would be neutron star. And then what if it's 4.6? According to this, it would be a black hole. And if it's like 0.3 mass of the sun, it would be a white dwarf, like our sun. When our sun collapsed, it would become a white dwarf, and its radius after collapsing would be it would be this one, 4,000. So yeah, that's all the question for today. I'm sorry, I'm a little tired, so I might have like stutter and ramble a lot. But yeah, I'm sorry guys, I'm a little tired today, but I hope it helps you guys. And it's my recommendation, always have these table or write it out so you can remember it easier. I like these. These are good reference for you when you do homework. So yeah, I hope you guys do well on it and have a good weekend. And I'll try to do better in the next video if we have homework. Thank you guys. Enjoy the weekend.